if you're interested, we do have a DerbyPy space on GitHub, and the app that I'm going to show you today is up there. I'm sorry we don't have better internet here. I actually have to use my Wi-Fi spot to get it. So we've actually talking with them about potentially getting better internet access here. So maybe next month we'll have that. This is called Flog. So I've used this before to talk about how to do certain things. And so this is kind of an app that I'm adding features to. The stuff that I added today that I'm going to talk about is all in one commit. So if you wanted to go through and look at and see like what I added to make this work, you could get a nice diff there in GitHub to see to see what I did to set this up. So what we're going to do today, so Flog is a Flask app. Flask is a web application framework in Python. It's pretty popular. It's not as popular as Django, but a lot of people use it. In the Python world, Django is kind of the batteries included framework. There is a lot that Django gives you, and there's not a whole lot of reasons not to use it. It's pretty configurable. It's pretty flexible. There's pretty big apps that are built in Django, and so it can get you a lot of the way. What I found in my company was that we end up in our applications something like, my guess is like 60% of the development we do is very probably not very complex, but relatively complex database stuff. And so what I found was that in our applications, the value to our clients that we were serving would be in really powerful database interactions and not so much in all of the batteries included stuff that Flask brought. And so because of that, we started to use a framework called SQAlchemy, which is an ORM. And SQAlchemy is probably one of the most impressive libraries I've ever worked with in terms of ease of use and the number of features. And so for those who don't know, an ORM is a library that sits between your Python code and your database, and it tries to do reasonable translations between working with objects in Python and what that means when you actually commit that data to the database. Oftentimes ORM, so Django has its own ORM, they built their own ORM, and a lot of times ORMs work nice for the simple stuff, and then you get to a place where you basically have to work around the ORM for the complex stuff. SQAlchemy is actually two-layered. It has its kind of declarative object layer, but then it has another layer between that that's really just, it's really just like functional SQL. And so the fact that you have two layers and when one doesn't serve you, you can go down to the second one, just ends up being a really powerful combination. And we found overall that that was the best route for level 12. And so most of our stuff is in Flask. That's why I usually do my presentations in Flask, because I just don't use Django. But if you wanted to start and you wanted really good documentation and you didn't have really, really complex database needs, you're going to get a lot of utility out of Django, and I'd actually encourage you to start there. There's going to be a lot more resources out there for it. They have really good documentation. But Flask is smaller. There's less to learn, and I think it's a bit easier. You can actually wrap your mind around the whole thing with, probably a week or two of study, depending upon how familiar you are with Python. So this application is built in Flask. We're not actually going to do anything with the web today. Flask also has a CLI built into it, command line interface, through a library called Click. In previous discussions and previous talks, I've actually set up some of this application and talked about how you tie these things in together. How do you get the CLI connected to the database? How do you test the database? We talked about some of that previously. And so all that stuff has been set up, and I'm not going to really repeat that. If you're interested, we do have those talks on YouTube if you want to go back and see what we did previously. Today I'm going to talk a little bit about task queues. And what task queues are is a task queue is the ability to take a piece of work and defer it to a part of your application that's separate from the main application. So if you're thinking about a web request, imagine that something comes in and you need to send an email, let's say. So somebody submits a form and you need to send an email. So a lot of times, a relatively naive approach to that would be in your code where you're processing that form response. Maybe you save it to the database, and then you make your SMTP call to the server, and then you end. And the entire time that your web user is waiting for that SMTP call to finish before the back end can finish, and they're served the thank you page or whatever it might be. Well, let's say one day all of a sudden your mail server starts having problems. It gets a bunch of spam in it, and it's taking 15 to 20 seconds to actually respond to the here's the mail request. How long is the user going to have to wait for that form to come back? Yeah, the whole time. Because it's all sequential programming. When we actually make that SMTP call on the back end to the mail server, that library that we're using is not going to come back and give control to my code until that mail has been sent and acknowledged. And if the server's sitting there having accepted the connection but not able to finish processing for some reason, then my app is hung up, which means the user's hung up. And our users, they're not going to just sit there politely. What are they going to do? They're going to start mashing the submit button. Okay, so now what are we doing? Now we're adding like 20 or 25 email requests to the same server. And if you got 300 people on your site, now you've got 3,000 requests to the already overloaded mail server. Okay, so what's happening now? Right? You're accumulating the problem. We could have another type of example where, let's say that when a user submits a file to me, I want to process through that file, maybe run it through some machine learning setups, and that's going to take 15, 20 minutes to finish, and then when it's done, I'm going to email the user. Well, obviously, they can't just sit there and hang tight while I finish that work or that analysis or whatever it's going to do. So it would be nice to have a system where I could say, hey, here's a piece of work to do, go do it, and then I could come back to the user and basically say, hey, I've done my job, I've submitted that work, you'll get notified when the work is ready for you. And many other uses. So that's...
What's this asynchronous method call here?
Say it again?
What is it, the library or whatever exactly that uses asynchronous sort of thing?
We're going to talk about that actually. This is it right here. Dramatic is the library that we're going to use. And so Dramatic is just the library that interacts with RabbitMQ. RabbitMQ is, what is it? It's a queuing system, right? Yeah. RabbitMQ is a service. It's a server. Message queue, thank you. RabbitMQ is a message queue that essentially takes messages are just bits of data, and sits on it until somebody comes in and requests it out of that queue. And it has all kinds of advanced things like routing, and there's all kinds of settings you can set in terms of like, do you want it to be really fast or do you want it to be persistent and like safe? And so it has all kinds of features which we're not going to get into. There are other ways to do that type of thing. We're going to use RabbitMQ for our backend. There's another popular piece of software called Redis that a lot of people will use for backends on this. You'll have to do some reading if you want to know why one's better than the other. If you just want to take my word for it, for most things that you're going to do, RabbitMQ is probably the better default choice because it's actually a messaging message queuing platform as opposed to Redis, which is really built to be a caching platform. So there's some differences, but they'll both work. Questions, just in general, about what this is or why you'd use it?
Message queues, are they based on message queue, like MQTT, and things like that? Or what's down below? This is a high-end Python module, and what's down below?
So down below it is the server, RabbitMQ. And it uses a protocol called AMQP, which is the networking protocol that it speaks to interact with the server. And now you're at kind of the extent of my knowledge. Like, to me, I consider RabbitMQ almost like Apache. Like, I know nothing about Apache other than it's a web server, and I know how to configure the few of the things that are important to me. RabbitMQ is the same way. Like, I don't really need to understand RabbitMQ a whole lot at my level. Now, if you were going to start building clusters and you're going to process, 10,000 messages a second, okay, now you have to have somebody who actually really understands the details of that system. But for our purposes, we're actually, this project even has a Docker Compose file, which sets up Postgres.
Important concept though is a channel of a message. The message queuing service can have multiple channels, and you subscribe to a channel, and you automatically get anything that's put onto the channel.
Yep.
Publish and subscribe.
Yep. For what we're doing, you don't even need to understand that.
It's like the default channel.
They're just default. Yep. And so in some ways I'm trying to keep this. You're absolutely right. I am trying to keep it simple. There are details, and you can actually use things like channels to set up custom processing. So for instance, I might have in my application, I might have some things that are really high priority. I want them to be taken off the queue as fast as possible. I might have other things like email that it doesn't matter to me if it gets sent out immediately or 5 minutes from now. The emails are not high priority. And so you can have different queues, and then you can have different workers assigned to those queues, and just through monitoring and the right setup of the workers, and the workers' number of threads, you can come up with a system, one system that's really high performing, and then another one that the queues are able to fill up, and that's okay. So it ends up being a really flexible configuration. In the Python world, you'll most likely encounter this with a library called Celery. Celery is a good library, but it also is really, really big, and it occasionally has bugs that are really, really hard to troubleshoot. And it's underfunded, and I think it's beginning to show some of that. And so I've been looking for something that would be a little bit simpler, a little bit easier to wrap your mind around when you actually want to go in and contribute to it. And I found this library that we're going to talk about, Dramatic is the name of the library. For the last couple of years, it actually had a license. I think it was the Afro GPL, which is really, what do they call that? Viral. Like you can basically only use it in other AGPL code, and a lot of times you can't license AGPL. So I avoided it because of the license that they used. They recently, actually, I guess it wasn't recent. It was about a year ago. They changed it to the LGPL. And I just came back and realized that they changed it. So that's cool. I appreciate that they did that. I think it's more usable this way. And so I figured I'd throw together a little tutorial here and just kind of walk through what it means to make this thing happen. Okay. That's not going to be helpful. Any questions?
I was just a comment really, so if you do this, your email example, and you're going to send it later into the queue so that you get it off and you can get your display back and all that, then doesn't it kind of complex what happens if it fails, and how are you going to tell the person that it failed? And I guess there's a lot of stuff that you could do, you could put it in another queue and try again, and
Yep.
email with that guy and try again, and I don't know, it just seems like that would be a challenge too, you've generated this work for yourself by doing that.
Yeah, you certainly can. It could be nice, it could not be nice, depending upon your perspective, is that Dramatic actually retries your tasks. So it assumes your tasks are idempotent. I think I said that right. Which means that they could be run again and again and again without any negative side effects. Chances are your tasks are probably not going to be idempotent. Not really. And so you're going to have to think about that if you use this library and some of its defaults. Now, all of those are configurable, but most people could get an email a couple of times, and it wouldn't be a big deal if for some reason it errored out, but the email actually sent. Something to consider. Okay, so the first thing we're going to do is I just want to show you here. I've got a virtual environment set up. If you're not familiar with what a virtual environment is, you definitely need to research that. You need to know what virtual environments are, and you need to know how to use them in Python. I know that as a beginner, there's a lot of things to learn, and a lot of things are important in Python. Virtual environment, it's absolutely something you need to understand. How to activate virtual environments will be part of that. I use a small tool called Vex. if you're on another one is called Virtual Environment Wrapper, which it gives you a nice way to kind of activate and deactivate virtual environments without having to manage the files like right there in your app. So just something to be aware of. So I've got that activated. You can tell on my screen because over on the left you can see flog in parentheses, which is what my shell does to remind me that I'm in a virtual environment. And so I've set all this up. The requirements are, oh, that's fun. I also have, I was going to say that earlier. I have Docker Compose set up here with the 3 services that you need to run this app. And so assuming you have Docker and Docker Compose installed, getting those services up and ready to go are as easy as Docker Compose up-D. The -D puts it in daemon mode so that you get your prompts back and all the output goes somewhere. It just goes to the bit bucket, so it's not messing up your screen. Docker PS, if you want to see those things running, you can see all those things running. You'll also see that I map all of my ports. I add a 1 to them for my Docker containers because I do run some services natively on my laptop and I don't want the ports to conflict. So you'll see I'm not using some standard ports in there if you care to notice that type of thing.
So these are services that are running external to your program that you're going to use to help you do the work.
Yep, that's right. So I've got Postgres for the database, I've got RabbitMQ for the messaging queue, and I've got Redis, which I'm actually using to store results. And so I'll talk about why I have to have Redis. You don't have to have Redis. You don't have to have a results backend, but for one of the things I'm doing, you need it. So I had to add that to it.
Like a web thing?
No. Redis is a caching server. Okay, so Docker Compose is there. The requirements are all here. There's a requirements file, so you could pip install -r requirements.txt to get your virtual environment ready to go. If you don't know what pip is, again, that's something you absolutely need to understand in the Python world, so take some time and research it and understand
Is that part of your environment, your virtual environment there?
the requirements.txt. It's just part of the source code. So so if you check this out from GitHub, you'd see the requirements.txt file, and then by doing pip install -r in this file, pip takes all these packages and puts them into the virtual environment so that they're ready for my application when it starts up. Okay, so I'm not gonna talk a whole lot about this application. I do want it to come back, and so I do have a command line prompt here. Let me do that again and clear some of this stuff. The command line works. It gives me output. You'll see I have an hn profile command, and you'll also see that I have a hello command. And so if you're here previously, you'll recall that I set up the hn profile command to go out to Hacker News, which is a popular site for news stories that have kind of a developer hacker feel to them. If you don't know what Hacker News is, I'd encourage you to check it out. There's a lot of good stuff there that'll keep kind of the goings-ons in the developer world. It'll just kind of help you keep up with things. There's also a lot of crap and vitriol in the comments, but not quite as bad as Reddit. Actually, not nearly as bad as Reddit, but you know.
What's the acronym FLOG for? File log or what?
Flask something. I don't remember.
It's like blog with flog?
Yeah, actually, I think that was. It was Flask blog because I have a blog data model in the middle of this for some of the stuff that I did. So, yeah, that's exactly what it was. Okay, so the first thing I want to do is I just want to show you a simple command line usage, which is to call flog, and then I'm going to call hello. And so I have that set up as a command here in the CLI function. And you'll notice that I have some options here to this command. And so this is how Click works. You can set up arguments and options to the command. I'm not going to go into that. Just to let you know that if you're interested in building CLI applications in Python, Click is a really nice interface to do that with. The docs are really good, and you can go read about how to do that. But essentially here, I've created a command that takes one argument for the name, and it defaults to world. And then I've given it an option, and the idea here is we have the default method of operation, which is just going to say hello world back to the user in real time. And then we also have a queue option, which is going to use our our RabbitMQ setup to actually queue that work for a different process to pick up and then work on. So when I run it this way, the output, the actual work that's done is in this OS process, the same one that the CLI is running. And so what I'm going to do now is show you how to set up other processes that are going to be reading from that queue. And when the work comes in, one of them is going to pull that work off the queue and do it. So let me show you what that looks like. I'm going to split my screen here. And we're going to put the junk screen up top. Actually, yeah, let's do that. We'll make it a little bit smaller. Now I do have to activate my virtual environment because the activation of my virtual environment is not going to carry through to the new shell. And with that active, I am now going to call, let's see. Okay, by default, Dramatic is going to set up a worker. So a worker, think of a worker as another, well, don't think of it, it is. It's another process that's just been created on your operating system. And each one of those workers has, or you're going to get a worker for the number of cores that you have on your system. So I have an 8-core system, and you'll see that I have 8 processes that started up there. I believe they said that each process also gets 8 threads. So you are running multiple processes with multiple threads. And so I should get the combination of 8x8, 64. So I should get 64 threads that can pull data off of these queues and work on them. Now Python is, because of the GIL, is pretty much a single process system. So the only time that threads really help with us is when we're waiting on I/O. Unlike other languages where you could actually have 2 processors running in the same process. That's not right. How would I say that? Yeah, I guess you could put work onto 2 processes and do parallel programming. In Python, you can't really do that. You've got to actually do multi-process development. So workers are helpful, but really threads are helpful, but really only. Hi, come on in. But really only in the context of I/O. So I can wait, I can have one thread waiting on I/O, and I can have another thread doing something, which is actually going to be really helpful for us because one of the things that we want to do is go out to the web and we want to pull down 500 pieces of data from the web. We're going to make 500 web requests. So if we do that sequentially and every one takes half a second, how long are we going to be waiting?
4 minutes.
Something, yeah, 250 seconds. Is that right? Is that what it is? 4 minutes? Something like that. Yeah, it's gonna take some time. All right, no, that's no problem. So it's certainly going to take some time. And since a lot of that time our computer is just sitting there waiting, what we want to do is like fan out that work, and we want a bunch of requests being made at the same time so that they're all working at the same time with the hope that they're going to come back and it's going to take a lot less time to do all that work. So that's what we're going to get to eventually, but the first thing I'm going to show you is just kind of how this works for a relatively simple request. So what we're going to do now is we're just going to say, hey, we want to do the same hello thing, but we want to do it in these other processes. So I set up the CLI command to take that queue option. And so now this process does something different. It just comes back and says, hey, I put that work on the queue. And you'll notice that one of our threads or one of our processes picked up that work and actually did it, and now we're seeing that same work done on a different process. Now, we wouldn't have to have these things working on the same machine. It could very much be the case that I had 3, 4, 5 web servers over here all serving web requests, putting data in a queue, and then I got a whole bunch of workers out here fanned out that are taking data off that queue and working on it. So this isn't technically distributed what I'm doing here because I'm doing it all in the same system, but this framework gives you the ability to have a distributed work queue by being able to take that work and push it off to other systems or other processes. Questions about the basics so far, what I've gone over?
So is an actor part of the manager and the worker?
Say it again?
Actor, what is an actor in relationship to a worker or a thread?
Yeah, we're going to get there. So you mean as you saw it in my program, an actor? An actor is a function that can be deferred by putting a message on the queue. So the sending program is going to say, hey, I want you to run this code with these parameters, and the worker is going to pull that message off the queue and say, okay, this is the function you want me to call with this data, and then it's going to call it. Question? Yeah, so you could do containers, but that's not necessarily baked into this. I'm actually running my services in containers. That's what the Docker Compose. No. Yeah, these are just, Dramatic has spun up 8 processes using the Python multiprocess worker, and each one of those workers has spun up 8 threads. So it's all doing it native Python. This doesn't have anything to do with containers as we're using it right now. You certainly could bake this stuff into a Docker container, but that's more of a DevOps decision. Anybody else? Questions? Okay, so generally what we're doing has been laid. Let's look at how we actually do this. So again, the Dramatic library is doing most of the heavy lifting here for us. The interface in Python ends up being really simple. So I have an actors file. And right now I have 2 actors. And again, actors are functions that have been instrumented to be able to be called through message passing. So if you'll notice, I did a say hello function, and it just prints the name it gave, right? Really, really simple. You can actually still use this function as a normal Python function. And that's actually what, let me close that so I quit clicking on it. That's actually what I do for the non-queued version. So I'm still calling that same function, I'm just not telling it to queue the message. So when I call it this way, this is just a normal Python function. There's nothing fancy going on at all. I'm calling it like I would any other Python function. But by decorating this with dramatic.actor, and I won't go into decorators, if you're in Python, you'll probably see things that are directors. Again, something very worth learning, understanding how they work, or you'll be perpetually confused when you get into more advanced Python code that uses it. By decorating this function with dramatic.actor, it turns it into something that I can use to do message passing. So going back to my calling code, instead of calling it directly now, like I did down here, and just pass it the name that's coming in on the command line, now I'm calling .send, and .send is part of the Dramatic API. So if you wanted to understand why do you call send, I just looked at the Dramatic Quick Start or the user guide and started reading through, how they told me to use it. And so I know to use .send because their docs tell me to do it. We're going to print to the user to tell them that I've went ahead and queued that message. I did that because at first I had some stuff messed up, and I was like, is the message not getting in there? Like, what's happening? So, it's always helpful to have a little bit of output when you're debugging. So this is it. It's really pretty simple, and your .send just takes the same arguments that you would give the function in the same order, whether they're keyword args or positional args, doesn't matter. You call it the exact same way. Dramatic takes that call, bundles it up into some JSON, puts that JSON message on the queue, on the RabbitMQ queue, and then we have those workers sitting there telling RabbitMQ we're waiting for messages. The message come in, RabbitMQ says, oh, I've got listeners for that queue, and it pushes it out to them. And Dramatic is even doing, it's probably doing 10% of the work of all of that. Like, most of that is just built into RabbitMQ and the protocol that it runs on. Okay, any questions about this so far?
Actor is a class, and say hello is a method inside the actor's class.
Say hello is a function. So in Python, actors is called a module. It's a file.
Say hello is a function inside of actors.
Say hello is a function inside of actors, and .send. So when we decorate say hello gets kind of packaged into whatever actor does with it. I haven't looked at the code. I'm pretty sure actor is wrapping that say hello function in a class that enables the message passing. That class then has a .send method on it. So actually, if I was to inspect this code, when I call if I was to look at this, in fact, let's just try that. Maybe this will be helpful. Flog shell from flog.actors import say hello. What is say hello? Yeah, okay, so this is a from the dramatic class, or from the dramatic library. They've got an actor class somewhere. This is an instance of that class that has these parameters on it. Does that make sense? Questions about that?
So that's what that decorator does.
That's what that decorator does. It wraps it in an actor class instance. Actor class instance. Okay. Any other questions about actors? Okay, so let's look at what the HN. If we go back now, I mentioned Hacker News earlier. So let's do Hacker News profile. Anybody here have a Hacker News account? Anyone give me the? You got one? Do you remember the username for it? Master Shake? Nope. Did I do it right? Is there capitals in it? You go ahead and give me yours when you get it. We'll look at mine. Okay, so we have some code in here that's going out, hitting the Hacker News Web API, which is a REST API. It's asking for the Syring data, and it's pulling out of that just a couple pieces of data that are relevant. So I've submitted 98 things, and I have a karma of 395. Okay. They also have a top stories API. That looks like this. So the top stories API is just a list of item IDs. And in a Hacker News API, an item could be a story or a comment. There's a lot of things that it could be. But for us, because we're asking for top stories, we know that they're stories. So what I'm proposing here is let's write something that hits this API, gets all the story IDs, and then prints out all of the titles and who the author is. Okay? So I've done the hard one here. We're gonna
So is this story IDs on multiple platforms?
You good? Okay.
Does their API come back as XML, or what does it come back as?
It's just JSON. This is Firefox makes it pretty by default, but this is what it looks like. So it's just text data and with a JSON header. Do what? Yeah, I don't know what they are. It's for what I'm going to do. It's not going to matter. Okay, so I'm going to write. I wrote this kind of the fancy way because I wanted to make sure I knew how to write it. We're going to create another one here that just does it really quickly. Oops, not if we delete all of the delete all the code here. Okay, so the first thing I might do is let's go look at Hacker News. So for top stories, all I'm doing is prepping the URL here, and then I'm using the request library, which is a really nice, easy to use web request library. It's doing a GET request, so it's an HTTP GET on that URL. It's turning the results by calling .json. Stop it. By calling .json, it's turning the text web data into Python objects. So that's going to take, and it's going to give me, because I know what the JSON looks like, this, I know that Python, converted to Python, this is just going to give me a list of integers, which is great. That's really easy to work with. So the first thing that I'm going to do here is just in the CLI, I'm going to print story IDs so you can see what we're doing here and how it's working. So flog top stories. Okay, so this has nothing to do with message passing. This is just pure Python. My laptop, when I hit that, when I tell request to go get that, it's making a web request. It's getting that data. It's coming back. It's converting it into Python, and it's spitting it out here. When I print that, then it's printing it out in just a nice representation, which Python does for most objects. Any questions about this so far? Okay, and so I could easily take those story IDs and run a loop over them and print them out by one by one. So now we're just printing them one by one. I did that mostly to show you I do actually have a list and some objects in there, as opposed to if I had forgot to call .json, it would have returned a text, and if I printed that, it actually would have looked a lot like thinking I had the Python, the Python version. So, any questions about this so far?
How would you sort it?
Good question. There's sorting functions built into Python, and you just Google that and find the functions. They're really easy to use. Okay, so I could also, if we wanted to do this the slow hard way, I could go one by one through all of these URLs and request the story. So let's do that. So the story, again, these are just really just web requests and take the JSON data. I'm going to go get the story ID. The story ID looks like this. Looks like item. Let's look at the raw data. So this is what the JSON looks like. Can everybody see that? So there's not a whole lot to it. It's pretty simple. And so I just want to grab the by out of this, and I want to grab the title, and I just want to concatenate them. Again, I'm not trying to do anything fancy here. Just showing you can get the data, you can extract it to the Python version, and you can use it. And so I'm going to use this function here in my CLI, and I'm going to call that story, and then I'm going to print the result. And just in case anybody missed it, all we're doing is, nope, that's not going to work. Okay, it'll work. That's fine. It just won't be the story in the title yet. But you'll see how slow this is. That's really my point. Okay, so if we got 500 of those, nobody wants to sit here and watch me see this, right? Or watch me do this. So instead of doing that, we want to use this task queuing system to take all 500 of those IDs and say, hey, you workers, go take and call the story function with this ID and do something with it. And so we have to create that actor. And so we're going to do the same thing that we just did. We're going to call story from Hacker News. That's going to actually go make the web request for us. We're going to extract a couple of pieces of data, and then we're going to return from the actor the combined, the concatenated string for that.
Is it going to cache all that?
So that's a really good question. So that brings us to results. So let's actually, you know what? Let me keep this up. Let's do it. We'll do it the easy way first. Okay. So rather than calling this, we would call actors.story, and we'd pass it. Okay, so what I want to do is I want to loop through all those story IDs, and I'm going to queue all those messages one by one. And then instead of returning here, I'm going to actually print this. Okay, so here's one got you. I just changed, yeah. Good catch. It's HN story. Come on, you didn't want to see the stack trace? All right, so if you'll recall, I just changed that return to a print. We'll talk about that in a little bit. So now all those stories and those titles are going to be printed where? In the CLI or in the workers console? Workers console. So all these messages are going to the RabbitMQ server. I've got a bunch of workers sitting there ready to do work. And when that work comes in, they're going to start churning on it. And you'll see that on the screen. We'll just see titles and stuff starting to go through. But here's the caveat I mentioned earlier that I didn't get to. But you have got to remember to restart those workers. If you remember, I restarted them earlier, and I just changed some code. Python, by default, is not going to pick up on the fact that that code just changed. It's already loaded. So you got to refresh these processes. There is a watch flag in Dramatic that you can use. I don't like it because every time you save it, it kills those processes and restarts them, and I don't know, that bothers me. There's no reason why it should. It just does. Correct, and that's only because I have eight cores on my system, so it reads how many cores you have and then decides to spin up that many processes, and all that stuff is configurable. But yes, that would be the default for my machine. It is 8 workers with 8 threads total. No, with 8 threads each. It's 60. There are 64 threads available to process work on my machine by default.
So does that mean it's doing in parallel?
To the extent that you can with Python threading, yes. Well, the processes are running processor parallel because they can all work at the same time, and then the threads inside of that process can work as long as they're waiting for I/O. Okay, so I'm going to start my workers again, and now I'm going to queue all of that work. That's not right. Oh, okay. So I called the function like normal instead of calling .send. So I didn't actually queue the work. I just did it. I did it right here. So I got to call .send. Now that'll be different. No, because the code I changed wasn't in the workers. It was in the CLI command. So we're going to see some of the. We're probably going to see some of the default error handling here. We're going to have some. I've noticed that you get not all these requests usually finish. Usually some of them time out. Although it may be possible that the internet through my phone is better than the internet at the office, because I was consistently getting timeouts and restarts. Oh, that's great, because I actually wanted you all to see that. Did they all finish? Yeah. Okay, so this is one of the problems, though, right? Like, I wonder if there's still some stuff that I should be waiting on. Now, I could use RabbitMQ tools to see if there's any messages still in the queue. But for a lot of times, for the apps you're developing, you're going to have other ways to monitor this stuff to make sure that it's, nothing's getting missed. So it looks like I'm going to assume everything got done here. But what if we actually had a situation where rather than just like printing those things to the screen, we needed to do some analysis on it, and we needed to wait for all 500 to finish? Then what do we do, right? Now we've got this weird situation where I'm queuing a bunch of stuff, but I got to kind of wait for it to be done too. Thankfully, Dramatic actually makes that relatively simple, but you have to enable results. So by default, yes?
Well, you might answer my question, so I won't hold it to
Okay, sure. So by default, the normal way of doing this, what you actually, the result of your calculations, so if I do something like this, Dramatic is not saving any kind of state related to this message. It doesn't know, all it knows is that it was taken off of the queue. There's no results. It doesn't know if it was a success or an error. It's not keeping track of the return value. There's no metadata about this at all once it's successfully removed from the queue by a worker. So I think they call that an ACK. You take it off, and then the worker says ACKs it, which tells RabbitMQ, I don't want to do it anymore. RabbitMQ takes it off the stack, and it's gone. It's done. You can't find it again. Dramatic adds an ability to save that metadata somewhere. And so that's where Reddit comes in for us. Reddit is not part of the message queuing system. Redis. Redis is not part of the message queuing system. Redis is simply being used to cache the the results and the metadata from our actors when they run. And then because it's a library and it's handy, it does some stuff to let us get access to those results. How do you hook it in? That's a very good question. So I have a dramatic library here, and I have a configure method function, and it's pretty simple. So the first thing I do is set up that Redis backend. Again, I have to customize my ports because I'm setting it up special because of what I do with Docker Compose. I'm setting up a RabbitMQ broker. Notice on the broker, I add middleware. Now, again, I don't really understand everything that's going on here. I just generally understand this is what the library told me to do to make this work. Like, I read the documentation about 2.5 hours ago and set it up. So you don't have to understand necessarily how all this stuff is working on the back end. But I'm telling it, hey, look, here's the results. The back end is this Redis back end, and I want you to add it to the broker. And then I'm going to assign Dramatic the default broker of the RabbitMQ broker that has the Redis backend, and it's going to handle all of the stuff to actually make that work. Sure.
Because they're using, I'm assuming since you're caching, that means like the data that's going on the queue is immutable.
Yeah. I don't think RabbitMQ would let you mutate messages on the queue.
So, all right. So how do you deal with like race conditions? If like something I don't want you depending on something in another queue?
Do what?
Only one queue.
Yeah. Well, so RabbitMQ is a messaging bus server. And so it is handling it, along with its networking protocols, is making sure that for this type of messaging queue, only one worker can pull that message off the queue. Is that what you're asking? Yeah, so all of that stuff is configurable. You could do pub sub, where I could put one message on and you might have 20 workers set up to all process. Every one of them is going to get that message. So it's very dependent on what kind of queue it is. For what Dramatic is setting up by default, this is all going to work well for single message goes to single worker. Okay, so yeah.
Can you set up Dramatic? I assume RabbitMQ can handle, I have events that are dependent upon each other. Can you do that with Dramatic?
You can. Yep, you can. So there are advanced workflows that kind of chain things. We're going to show grouping, which is kind of a primitive to do that kind of thing.
So if you're writing like a microservice architecture, and your different microservices don't want to have a single file and whatever service will be, you will have like pub sub and then
Yep.
like that. So
Sorry, say it again. Yeah. You can. RabbitMQ, the underlying system, is incredibly powerful and incredibly flexible. Dramatic and Celery. Celery is kind of a competitor, a more advanced competitor to Dramatic. Both of those libraries have configuration options for how you actually want to set this up. I'm pretty sure Celery is going to be way more configurable than Dramatic is. Dramatic is kind of deliberately keeping things simple. And then if you got yourself into a situation where that wasn't sufficient, you can just use the AMQP clients directly and set all this stuff up yourself. So there really is a lot you can do to do fan outs. You can do all kinds of stuff with RabbitMQ. You just have to see which libraries best support what you're trying to do. And if they didn't support it, you might have to interact with RabbitMQ directly, over its protocol as opposed to using Celery or Dramatic.
So RabbitMQ and ZeroMQ and the other things like that, none of those are Python specific at all, right? So
Correct.
Celery are like the Python middleware to talk to these backend message bus systems, right?
Correct. And you could hook up, so you could have a C system, putting messages on the, or Python system putting messages on the queue, and you could have some really fast C processing systems pulling them off. The library that I'm showing you is designed to be Python on both ends, and it's taking out a lot of the hassle of synchronizing that. But at the end of the day, the messages in RabbitMQ are just text, and they have Dramatic even has some it has kind of a specification of what the message is in case you want to interact with it in different languages. It's just JSON. Good? Okay. So we've set up that results processor or the results backend. And so now I went from a print statement to a return statement. So now I've got the actor, I want it to return something. If I don't set up a backend and I don't set store results equal to true, I'm going to return and Dramatic's going to do nothing with it. It's not going to be available to me anywhere. It's only by setting up the backend, the results backend, and then setting store results equal true that trigger actually doing something with that metadata.
It's actually even worse than, if you didn't set that, if you set that to false or left it off, it's not that Dramatic wouldn't do anything with it, it would be more like it got dropped and it went nowhere.
Yeah. I mean, in Python, the function is going to execute, is going to return a value, and that calling code is going to do nothing with the return value.
What is back off value is milliseconds or what?
Back off value is milliseconds. Yep. Okay, so let's now think about the situation. Going back to what we were doing earlier, Hacker News, I got 500 story IDs. I want to get all of that data, but then I want to do something with it. But I got to wait for every one of them to come back. I still want to use the task queue to do the distributed processing because I don't want to wait sequentially for every one of those to come back. But I want to do something in my calling process when all of those URLs have returned. So we're going to go back to the CLI and I'm going to uncomment this code. So Dramatic has the concept of groups. Groups are a way for me to package up a bunch of work, let Dramatic work on it, and then return to me when that work is done. Does that make sense? So this is how it works. I'm going to start off by, instead of calling send, I'm going to call message. So this is a different actor method, actor being the class. There's a different method that instead of taking that data and actually giving it to the broker, it's going to package up that work and return it to me. And so this thing here, if you're not familiar with it, it's called a list comprehension. This is a really nice, concise way to do a for loop, essentially. So I'm just looping through this stuff and calling message on every story ID. If you've never seen one of these, you want to write down list comprehension, because if you come across this in code and try to figure out how do I Google this, it's basically impossible. I'm sure that Python IRC is full of people pasting list comprehensions and going, what do I call this? So I can Google it. It's just, what is this? Okay, so that gives me a list of messages. Messages are going to be, I don't even know what they are. It could be IDs. I'm guessing it's some kind of like class instance that Dramatic has come up with. And it told me, the docs told me that there was this thing called group. I can feed it the messages, and then I can call run, and that is going to take all of those messages then and send them off to the workers to be processed. Then I'm going to, on that group instance, I'm going to call get results. I'm going to block, and I'm going to wait up to 60,000 milliseconds. Yep. Yeah, so this is actually new in Python 3. something, where they allowed you to put in integer literals, they allow you to put an underscore, which they collapse to nothing.
And I don't get IntelliSense. Why am I not getting IntelliSense
Just,
in Python?
just not configured right, I would guess. Google Visual Studio Python syntax highlighting, and I'm sure it'll take you to the first result. But yeah, I mean, trying to program without syntax highlighting, I give you all kinds of kudos for that. It's really hard. Okay, so because of all the work that Dramatic is doing behind the scenes with the results, the workers are getting the data, they're getting the messages off the queue, they're processing them. Our functions are returning a concatenated string. Dramatic is taking that result, packaging it up in some metadata, pushing it into Redis, not Reddit, pushing it into Redis, and then this process, my CLI process, is able to access that Redis data, figure out what the results are for the message IDs it's holding on to, get those results, turn them back into Python, and then give me the result as an actual Python thing that the actor returned. So I should get a string that's a concatenation of title and author when I call result.
So is that result going to give you like a count of how many results you've got to? Like how many messages are in there?
You can get that off of the group instance, but I'm not demonstrating that here.
Your result loop is a subloop of your sid loop.
Say it again?
Is your result loop a subloop of your sid loop?
Nope. This thing starts and ends right there. It just loops through all the story IDs, calls .message for each one, and puts that result in a list. So that loop is done, and messages is now a list of the results of calling this. Okay, so once I get my results back from these completed group messages, I'm just going to print them. And so it's unfortunate that the way that this implementation works, if I have a worker at the very beginning that hangs or is slower, this actually gives me them back in order, so it waits. I'd love one that just yields the results as they come in. I didn't see any API for that. So
What's the block for then? Is that blocking for false when you return the message again?
no, I think what that would actually do is it would just immediately return, and it would only give me the number of ones that have finished. I didn't try it. We could try it here in a little bit and see what breaks. Okay, so let's actually watch this thing run. Oh, no. That's right. Stop it. Anybody? Okay, what did I forget to do? What happened? I didn't restart my workers. So instead of returning, they're just printing the result. All right, so let's try this again. We'll start our workers. And now, there we go. Well, it was printing them in order. If it was printing them as, so I think what was happening is it was getting to like number 10 or whatever, and then it was waiting because number 11 was hanging, even though 25 through 40 might have finished already.
The block didn't mean wait for all of them to complete before returning.
No, I think what it really means is as you loop through them, if you come to one that's not finished, wait for it. Let's see what happens if we remove that. Oh, so it's even going to do worse than that. It's going to tell me your result's not there. I guess we could, I wonder what would happen if we did. Say it again.
Group.get results even going to be iterable if you get none back or something?
Oh yeah, where did it? Oh, you're right. I'm not going to even get there. It's breaking in the loop. No, that's okay. I can undo the break. It's pretty easy. Yeah, that makes sense. So I was actually, if we had enough time, I was actually going to try to see if we could implement the iterator version of this, but I think we're good. Okay, so any questions? Okay. I'll hang around if anybody's got any individual questions. Happy to. Yeah, sure. Like, could I hit Instagram instead of Hacker News? Yeah, I mean anything that has anything that's available like from a web request, you could hit that instead of Hacker News. Absolutely. No. So if you're trying to like scrape Instagram stuff and get it onto like a different web application, you're going to have two systems running probably. You're going to have your scraper, which is doing everything in the background, probably saving that data in a database. And then you'd have the web application going to that database and showing the data that's already been scraped. Come to me afterwards and I'll see if I can find some. I don't know them off the top of my head, but there's a very popular web scraping library that I could show you. I just got to Google for it and I'll know it when I see it.
I think a couple people know what web scraping was.
Web scraping? Web scraping is just having a process that goes out to the web and hits a website and takes the data off it and does something with it. Screen scraping. Yep. Beautiful Soup is one. There's actually one though that's like built to be a spider, so it handles a lot of the hard parts of scraping in terms of like the network requests and errors and that type of thing. Anybody else? Questions? Okay. Thanks for coming. Have a good evening.